This video can prove the following fact. If a to the fifth equals e and a inverse equals b squared, then the order of b is either 1 or it's 31. I should also mention this is all happening in a group G where A and B are members of the group. If you like watching mathematical proofs, please subscribe to my channel. Okay, now if a to the fifth equals e, note that 5 is prime, so we have two cases. A equals e or a does not equal e. Okay. If a equals e, then a inverse equals b squared simply becomes, remember those are e's, so the left side is e, the right side is b squared, but that implies that b is the identity, because the left side is a eb and the right, which is b, the right side is b squared. I kill off or b on the left side of the equation on the right hand side, and I did the same on the right hand side of the right hand side, and I got e equals b or b equals e. Okay, so this is what happens if a equals e. Now we're going to look at when a is not equal to e. So let's say now suppose a is not equal to e, and of course a to the fifth is e. For the record, if a is equal to e and you raise both sides to the fifth power, you also get that a is equal to a to the fifth, is equal to e times e 5 times, which is just e. Okay, so this basically implies, these two statements implies, since that's prime, that the order of a is 5. You don't need this, but it's still true. So now, as we were told, a inverse is equal to b squared. Now I am going to square both sides. I'll square the left side over here times itself. Well, that becomes identity. So you have a times b squared times a inverse. That's what the left side's going to become. And the right side is b to the fourth. But we still have another way. We still have that same way of writing b squared. Right there, I'm going to put the alternate way of writing b squared. That's b squared times a inverse equals b to the fourth. Well, a times a is a squared times b. A inverse times a inverse is a to the negative 2, and this equals b to the 4. Well, if I square both sides again, I'm going to get a squared b squared times a to the negative 2 is b to the 8. Now play the same game. I will replace b squared with a inverse, and I will get a cubed times b times a to the negative 3, and this is b to the 8. I will square both sides once again. So I'll get a cubed b squared a inverse a to the negative 3, excuse me, is equal to b to the 16. And I will just write, instead of b squared, ab a inverse. This is b to the 16. That is a to the 4th times b times a to the negative 4. This is b to the 16. I will square both sides once again. So I'll get a to the 4th b squared times a to the negative 4th is equal to b to the 32. But we're almost there. Once again, I'm going to write b squared as a, b, a inverse. This here gives me a to the 5th times b times a to the negative 5 equals b to the 32. This is e. A to the 5th is e, so a to the 5th inverse is e inverse, but another way of writing that is a to the negative 5, and e is its own inverse. So a to the negative 5 is also e. We have e times b times e equals b to the 32. So that means b is equal to b to the 32. Let's get rid of this side work. Killing off 1b on the left side leaves e. On the other side, killing off 1b gives us b to the 31, which is prime. This implies that b equals e, or let's say it differently. This implies that the order of b is 1, or the order of b is 31. The order of b equals 1 implies that b can be e. Or the order of b is 31. In fact, they just asked us for the order of b. So we have that answer if a is not e. So if a is not e, then we get this. And if a happened to be e, if a equals to e, that means b is equal to e, which implies the order of b is 1. So either this statement happens to be duplicated down here without any further information about a, the order of b is 1, or the order of b is 31. If they tell us that a does equal e, then the order of b is 1. That was the first case. If it turns out that a is different from e, then the order of b is 1 or it's 31. We don't know. And that completes this proof. We've already stated if a is not equal to e at the heading of this case. If you like watching mathematical proofs like this, you should seriously consider subscribing to my channel, as this is all we do here. We do mathematical proofs. If that's what you're into, give it a try. Click the subscribe button. If you like this video, please click the like button. Please leave a comment. Hopefully I'll see you guys in the next video. Watch and learn.